I doubt that there is anyone in this room who doesn't know the name Katerra. And this morning it's my pleasure to introduce Craig Curtis, the Chief Architect for Katerra. Craig is going to give us an update and a much closer look at what Katerra is doing and where the company is going. Before joining the Katerra team, Craig was with Miller Hull Partnership for 30 years, where his projects included the Bullitt Center, the world's first commercial office building to meet the stringent requirements of the Living Building Challenge. Craig's success with the design of many award-winning projects was possible because of his integrated approach, relying heavily on his team of architects, engineers, and contractors to solve complicated problems simply, creatively, and elegantly, and most importantly, together. As president of Catera Architecture, Craig is taking that same approach to a new level. Please, let's give Craig Curtis a warm welcome.
Thank you, Art. Welcome, everyone, and glad to be here in Boston. So I thought I would try to get through this in maybe about 40 minutes and then allow for some questions, as long as nobody asks me any questions about WeWork or SoftBank, okay? Actually, I'm just kidding. I'd be happy to answer those questions. I just hope we're not dominated with that kind of a discussion. There are a lot of other more exciting things to talk about. Impressive group here. I have to say the exhibit hall is super impressive. All the heavy hitters are here. That was really cool to walk down there and just see this room filled with all these familiar names. Nice to see a lot of familiar faces and met some new people last night. I really do feel like this mass timber movement is like this club. It's really fun to go to these conferences and keep running into the same really great people time and time again. Believe me, it's way better than a AIA conference. And I want to say, last night I was talking with Michaela from PFS Tico, and she was mentioning something. I kind of feel the same way, that the vibe at these events now all of a sudden feels a little bit different. It's no longer like we're talking about colonizing the moon or delivering packages by drone, but it feels like this is real, like this is actually happening. This is no longer, won't it be cool when we're building mass timber buildings, but this is actually happening, and happening really fast, so super exciting. I thought what I would do, since I've got a little extra time today, is talk a little bit about how Catera got started. A couple people asked me last night that question. I thought, well, maybe people don't understand, where Catera came from, and a little bit of the DNA behind Catera. And it all starts with our founder, Michael Marks, and he is the visionary that started this company. And the story goes something like this. He became friends with a gentleman named Fritz Wolf, who was the third generation owner of the Wolf Company, a multifamily developer based in Arizona at the time. They were skiing buddies. They met in Sun Valley, and they became pretty good friends. Michael had retired from running Flextronics, so he took over an electronics manufacturing business when he was younger. It was about $150 million a year in revenue business. And he took that to about a $20 billion business and became number 2 in the world in electronics manufacturing. So that was Michael's background. And he started talking with Fritz about real estate, just because Michael's this really curious individual. And they happened to be touring a project site in Seattle, and there were 2 buildings going up by the Wolf Company within view of each other. And Michael said, well, Fritz, you must be getting a great deal on doors and windows and sinks and faucets and drywall, because you've got these buildings right near each other. And Fritz just laughed and said, no, that's not the way this industry works. You see, we have different general contractors. They have different subs. Each of those subs has their own suppliers. And he said, I have no idea who's going to supply the doors on either one of these projects. And Michael just couldn't believe it. He was like, that's the stupidest way to run a business I've ever heard. He said, I'm going to help you. So Michael took it upon himself, because he is a supply chain guru. He said, I'm gonna make some calls, and he did, and he assembled a team, and he sent them to China. He said, I'm going to start a supply chain for the Wolf Company. And this is Katerra's first idea, was just simply a supply chain company for Wolf. And so this team went to China, and they came back after a few weeks, and they had identified some great sources of sinks and faucets and windows and doors and everything that you need to build an apartment. And sure enough, they said, I think we can save 25 to 30% just by going contract direct to these manufacturers, just like you did in the consumer electronics world. And Fritz said, that's fantastic. And then they tried it, and it was a complete failure, because no contractor wanted to just accept somebody else's materials forced on them without marking it up even more. I mean, they all have their own subs and their suppliers that take them salmon fishing every year, and they're not about to just accept somebody else's materials. So then they pivoted and said, okay, I guess we better become a general contractor. So this is late 2015. The idea all of a sudden shifted from supply chain to supply chain and construction. And then Michael, because when he left Flextronics, he had 350,000 people working for him, and he had factories in 30 countries. So he was a factory guy. And he said, we cannot continue to build these projects out in doing all the labor on site. We're going to start building factories. So they launched into a factory in 2016 in Arizona. And at about that time, I got a call from Fritz Wolf's brother, Pete, who I happen to be really, really good friends with, telling me about Katerra. And that's when I jumped from Miller Hall, joined Pete and two other guys. So there were four of us, and we opened the design office in January of 2016. So, I mean, the story goes from supply chain, construction, offsite manufacturing, finally design. Architecture and engineering came in January of 2016. At that time, we were about 40 people worldwide. So that's a little bit of a history of how it all started. And this is Michael's world. So not only did he run Flextronics, and number 2 in the world in consumer electronics manufacturing, second only to Foxconn, but at one time he was asked to step in as CEO of Tesla for a year for Elon Musk, just to run the company while Elon was going through some tough times. So Michael has a pretty interesting background, and this kind of growth and this kind of disruption is nothing to him. So that's Michael's world, and this is mine prior to Katerra. So I liked starting with this. How many people in the audience have any familiarity with this building? Do you know this building? There are probably quite a few people who have seen the Bullitt Center. A number of hands go up. So the thing that's interesting is this is just a 50,000 square foot commercial office building in a kind of a side neighborhood of Seattle. Nothing special when you think about the program, but Dennis Hayes, when he envisioned this project, it wasn't about just doing an office building. He wanted to change the conversation about how office buildings are designed. This is the first commercial office building to meet the challenge of the living building challenge. So it's net zero energy, net zero water, meets the red list for materials. So he wanted to shift that way of thinking about doing these office buildings. And to some degree, I think it was pretty successful. I mean, this is a project that has been copied across the country, and I think it's gaining more and more momentum all the time. And at Katerra, I feel like it's similar. We have a similar mission, that we're not about just doing one project, one building. We want to try to change the industry. I think that's why everybody in this room is interested in the same thing. There are a lot of reasons why that we all believe that way. One that's extremely important to us is the fact that there's a massive shortage of workforce housing around the globe, and especially right here at home in North America. It's just excruciating to see the home prices and the quality of product that's out there for people like my own kids to move into. If you're in that 80 to 120% AMI category, which is the vast number of people in America. Of course, the other factor is just simply the amount of building that we have to build over the next few decades is astounding. So if you take those two things together and then lay over the fact that it's been pretty well documented that the construction industry has had the least amount of gain in productivity since World War II of any industry. You can see the orange line there. That's construction. That's right below mining. Right below mining. Unbelievable, right? So we're dead last of any major industry in terms of productivity gains since World War II. So how can we possibly achieve those other numbers if this is current status quo business? We have to change the way that we think about designing and building buildings. So that is why Katerra exists. We see this as an opportunity. This was, Michael's vision. He saw this as not a challenge at all, but a huge opportunity in this, over $1 trillion industry just in North America alone. So what we're trying to do is essentially what Michael did in the consumer electronics, is create a vertically integrated company. So we are everything from architecture and interior design and engineering. We do off-site manufacturing. We do have our supply chain for everything that we do. And then we are a general contractor, and we're quickly becoming a licensed general contractor in all 48 states. And the other thing that's interesting about working at this company is not only Michael with his background, but the company is run by people from the tech industry. So the vast majority of our C-suite is people from these companies. You see here, we have a brand new COO came from the oil and gas industry, Schlumberger. A lot of tech executives in the company, and you can see we've grown pretty rapidly from when I started at employee number 40 in January of 2016 to 8,500. The growth has been pretty amazing. About half of that is in North America. And this is how we're spread out across North America, primarily in the United States, with a couple of exceptions there. And then you can see to the lower left, we've got a fair number of offices in Asia, mostly in India through an acquisition of a company called KEF Infra. So it's a precast concrete company over there and a very, very top-notch engineering and architecture firm. So it's essentially another version of Katerra in India, primarily building workforce housing in India and throughout the Middle East, specifically Saudi Arabia, and then also some very large precast buildings. So it's the same idea, different material over there. And you can see our spread across the U.S. The design headquarters where I live is in Seattle. We have made some acquisitions, one of which is Lord X Sargent in Atlanta, so that will become our second design headquarters, and then you can see things spread out. We can talk later about factory expansion if you'd like. We've got factories that I'll show you later in the presentation. So how do we drive efficiency into what we're doing, and how do we change the way we approach design and construction of buildings? So if you think of the way that typical buildings are conceived, from engagement of the customer through delivery, there are two significant improvements that we're making. The first one is when it comes to designing buildings, we're designing products or building platforms, we call them. So these are very specific market sectors that we're taking on that we can develop a platform for that is repeatable. There's a lot of repetition that goes into this process, and we can bake that into these platforms. There's still practicing mass customization, but trying to take a lot of that bespoke work out of things like multifamily housing. And then the second thing we can do is with the supply chain. So if we can move all of that decision-making of material specification up front and have that baked into the model, you can imagine how much time that saves in the overall process with specifying and shop drawings and all of those approvals that usually come late in the game. We push all of that upstream and make all those decisions. That process makes, those two things make that entire process much more streamlined. So as Art mentioned, we started with the launch customer, the Wolf Company, and so the multifamily market sector is our most mature. And within the multifamily sector, what we're doing is we're designing from the inside out through manufactured assemblies. So within our factories, we can make kitchen kits and bath kits, and we own the supply chain of sinks, and we make our own faucets. We make our own windows. And anything that goes into an apartment building, we try to control as much of that as we possibly can, and that becomes our building platform. And then my role as chief architect is make sure that this does not become cookie cutter. And the often overused analogy is, or metaphor is the automobile industry, but I'm going to use it anyway because I think it's a good one. So when you think about when you pick a car, if you buy a new car, you've got options on the inside, and you know for sure that no matter what option you select out of that catalog, it's going to look great because that manufacturer owns the supply chain, and they know every possible combination, and they're not going to put something in their catalog that doesn't look great. And so we're taking that same approach. So we have a narrow supply chain, a narrow catalog for our multifamily sector, but we know every product has passed our test, not only for aesthetics, but for environmental responsibility, for social responsibility if these products are made in Asia. And so any combination of these materials we feel really good about. Then we can also go and design our own products where we feel like we want to have even more control over those things where the customer actually comes in contact with. If we don't see something in the marketplace that meets our requirement or meets our price point, we'll go straight to the manufacturing floor in China or wherever and have that product made, put our name on it, now under the brand Kova, which you can go online and you can now shop for things like door hardware and plumbing fixtures that are a Katerra brand under the Kova brand. So we have a light fixture line, we have accessories, fixtures, and we'll continue to expand that Kova brand of things that we feel really good about. They're beautiful products, very high quality, and we can provide them at a very, very good cost. What that means is, again, like with the automobile, if you select multifamily unit from us under one of these different finish options, you know that the interior is going to be very well choreographed, and we don't have to go back and pick everything late in the game. All of those selections are made early. They're baked into that model, into that building platform. And on the outside, then we still have choices to make. So the inside might look the same on this building as it does on this building, but the exterior can be modified. It's that idea of mass customization. And to explain how that works with specifically to workforce housing, this is our workforce housing model, and across the top of the page, we only have 3 plans. This is a 3-story, 24-unit garden product. This is all over America. There are 15 million people in America who live in this type of housing, and it's pretty much ignored by the AEC industry. I can guarantee you that this is not a market sector that would get any architect excited about working on, except now when we're doing it as a platform, and you think that this could actually be rolled out into thousands of units and have a positive impact on people's lives. Now it starts getting people's attention. So we're really excited about this product. So three different units, optimized, very few, there's a very limited kit of parts that we have to be responsible for. Each of these manufactured assemblies we want to be able to make in our factory. And then the planning is very smart. So you can see on the bottom of the page, all of the services are organized along one floor panel. So when we look at that floor panel, this is that same part of the building in the floor panel in the upper right. That floor panel then can be manufactured in our factory, fully loaded with all of the services. So when that is dropped on site, that's it. All the services for those 2 units are completely done in that one assembly. And that allows the rest of the building to go together very, very quickly. So it's that kind of thinking that's been really interesting as an architect to work for Katerra when we're thinking about putting these buildings together more as you would assemble a phone or a printer or an automobile or something like that. It's really we have to take it to the level of a bill of materials, which is not common in this industry. So we have to think about manufacturing in a new way. We're still trying to apply lots of options on the outside, though, so you can meet jurisdictional requirements, provide that kind of variety, provide that mass customization. So in the case of our workforce product, we have different materials, different colors, and different arrangements. All of those components can be made in one of our factories, one of our component factories. Currently, we have one in Phoenix, and I will not be showing you that today because I think it would be embarrassing to this crowd. We've got a sophisticated group here who understands what it takes to put together an automated factory, and the Phoenix factory is not an automated factory. It's factory 1.0 for us. We learned a lot, but the factory that you see here is under construction in Tracy, California right now, and this is one that we're going to be very proud of. We've taken a lot of lessons from our first one, applied them here, so we've got a lot of robotics that are going into this factory. It's over twice the size at 600,000 square feet, but will employ about the same number of people as Phoenix. So the lines are much more automated. We're using self-guided vehicles for a lot of delivery around the factory. And we're excited about this factory. And then this will be copied again in Texas next year. And then we'll look for a place in the Northeast probably the year after that. So the goal would be to have 4 or 5 of these factories across the country within the next few years. And this was just taken with an iPhone a few weeks ago, but just to show you some of the technology that we're incorporating into this factory in Tracy. And this is just a little snapshot of what a lot of our lines are using KUKA robots and so on in order to automate a lot of the processes. You know, the window line is very much automated. Window line is in production right now. We're just commissioning this factory, so it's not up and running, but it'll be impressive. But I wanted to move on to mass timber now because this is really what gets me excited, and I think what most people in the room get excited about. And I will admit, just to be fully transparent, that the component factories we're primarily building with cold form steel. You saw wood framing there. We do have one wood line in Tracy, but most of our framed buildings are moving in the direction of cold form steel. For a lot of reasons. Happy to talk about that later. But where we're really using wood is in mass timber. So let's talk about that. And one thing we did when we made the commitment to go into mass timber was we went out and acquired some talent. So Michael Green Architects and Equilibrium Engineers, these are 2 of the premier design companies in the world when it comes to mass timber. They're now part of Katerra. It's awesome to have them on board our team. They bring a wealth of knowledge and just credibility in the industry. So they're up in Vancouver, BC. Lord X Sargent in Atlanta is going to be, our second design headquarters out east. And then we've had a great relationship with some research labs, one in Austria and with Professor Schickhofer. And then, of course, Washington State University has been a tremendous help in getting our product approved in our factory in Spokane, which is only 75 miles from Washington State. I see Ryan Smith here from Washington State. Go Cougs. I'm an alum. So it's exciting to see the work that's been going on there at Washington State. We continue to work with them. We have a pilot press that we have there, a 12x6 press, and we could never have gotten our factory up and running in the time frame that we did without the involvement of Washington State University. So these partnerships with academia, as Pat's here from Clemson, those partnerships are super important to companies like ours as we're trying to ramp up. Having those connections to those types of facilities is essential. A few shots of our factory that just came online in July, and a couple comments about some of the features. So in the front end, we've spent a lot of money on a sorting line. So we have a decoupled sorting line that's pretty impressive. And right now we're visually grading, but we'll be moving into MSR and E-grade material using this equipment to its fullest potential, and we're very excited about that. We have our own kiln, which is a little bit unusual as well, but we wanted to make sure that we were hitting the moisture content very specifically. So, we're very, very serious about quality control in this factory. This is coming from the background of our founders. And so if the moisture content is not correct, we can simply just touch up that lamb stock with our own kiln. You can see our planer line there, the press, layup and press. Happy to see USNR here, and thanks for the cocktail last night. These guys have been great in getting this press up and running in record time. And then, of course, the CNC and finishing line. We have 3 CNC machines. That's typically a backup in the production to get output in speed increased. And so we've picked up our 3rd CNC machine. And then we've done, obviously, a lot of testing. We've had to go through the fire testing, all the strength testing we did at Washington State, acoustic testing. We're heavily involved in some seismic testing down on the shake table at San Diego. And the other thing that's exciting about this company is there's a pretty enormous investment into R&D, which doesn't happen in this industry. About 1% of revenue in the construction industry goes into research and development. I would say probably about the same in architecture and engineering. We're investing more than that. And one exciting part of investment that we have is we've got a little AI lab up in Toronto. That's kind of a hotbed for the AI industry right now, and maybe Phil will talk about that a little bit later this afternoon. But this team is pretty excited about helping us out with our mass timber challenges, and specifically around this sorting line, and as we move to E-grade material. And they can help us writing these very complicated scripts to make sure that every board that comes in and gets scanned, that we'll understand exactly the properties of that board. So if you have wane on 2 boards, you can't have that wane lie next to each other because it will create a big enough void that it doesn't meet the specs for glue coverage. So we can read that material, that information, and it can figure out exactly where to put that board, face up or face down, in an entire lamella in a panel, 12 by 60. So that layout can be done in a way using artificial intelligence to help us with that we're going to hopefully cut waste down significantly. So we can take a lot of those boards that typically would be thrown out, and we can find a place to put them in that CLT panel without diminishing the structural properties. So we're excited about that. Here's just a little video of the Clt Factory. This hasn't even been published, I don't think, on our website yet. It's a brand new video that just was put together. Again, we just opened this factory in July. It is a quite impressive plant. When it's at full operation, it will be on par with the big plants over in Europe, the Stora or Binder or KLH. So about 180,000 cubic meters a year when we're at full capacity. You know, we're just ramping up now. We're running 410s and just trying to get everything commissioned. And we've got a good pipeline of projects, but we're definitely looking for more. Definitely a sales pitch here. If anyone's looking for CLT, we do have some capacity over the next 12 months for sure. You can see the press. Thanks to USNR. Again, this was pretty remarkable how quickly this all came together. It's a very complicated factory. The biggest investment that Katerra has made to date is this CLT factory in Spokane. These are stacked up. These rib panels are these are the first panels to come out of our factory, and luckily and coincidentally, our very first project happened to be in Spokane. So they had to drive down the road about 15 minutes to the job site. Logistics costs were really good. So I'm going to give you a little bit more information about that particular project. This is our first project out of the factory. It was seen as a spec office building, but then they found Eastern Washington University willing to move in, so it quickly became an academic building. So this is right across the railroad tracks from the multi-university district in Spokane, where University of Washington, Washington State, Gonzaga, Eastern, Whitworth, there's a lot of universities who have space in Spokane. They built a pedestrian bridge across the railroad tracks to South Landing, and this is the first building in that new development. And I think this part of Spokane is really going to take off. So it's divided into 2 with a common 2-story atrium. And because the Eastern decided to move in here, we quickly realized that we needed to expand our column grid to provide 900 and 1,200 square foot classrooms. So what you see here is a typical classroom floor. So you see a combination of small and large, or medium and large classrooms, and a perimeter corridor around the core. To get that 30-foot span meant that we had to add some glue lambs. We can't get that kind of span out of a 5-layer CLT panel. And so this is a technology that we saw being used in Austria, decided to adapt it here, and I think this is the first application of this product in North America. What you see in this section here, the rib panels over the classrooms at that 30-foot span, and then in the center we add an intermediate beam. You can see that that's dead center on the core. That cuts that span down to about 15 or 16 feet, so we don't need the ribs. That allows extra height in those corridors to run our trunk lines of ductwork and our cable trays. So, all of our main services are run around that corridor where we don't have the ribs, and then we feed over the top of that big girder and in between the ribs into the classrooms. This is a 2-story atrium space. This was a building that was designed with Michael Green right before he joined Katerra. We worked on this together, and then he became part of Katerra. So it was a good collaboration between Katerra and Michael Green Architecture. 2-story lobby. And then this is somewhat unique about this building as well. The exterior skin is being constructed with a 3-layer CLT panel. Now, of course, we certified a 5-layer panel right out of the gate in July in our factory, but we don't have a 3-layer, at that time did not have a 3-layer panel certified yet. And so we turned to our friends up in Penticton at Structure Lam. So these panels are actually from Structure Lam, and these are 2-story, 3-layer panels with all of the exterior insulation on the outboard side. So super high performance panel, triple pane windows. So it's passive house technology on the exterior skin, R value of about 40. So this is designed to be a net zero energy building when it's done. These are those first panels in our factory. The rib panels coming together. We put these together in the factory. They dropped right into place. This is what it looks like under construction. This was taken about a month ago. And a little video of the panels coming in. You can see flat paneled, no ribs around the core. That's what we're dropping in right here. This building is now topped out. Most of the exterior is on. We're just starting with the exterior cladding system and starting with all the MEPF. So pretty exciting. First project out of the factory went together so well. We couldn't believe it. I mean, it was just like everyone's dream. It just went together as quickly as everyone had hoped for. And the panels just fit like a glove. This new way of building is really exciting, and everybody in our company is ecstatic about how it's going so far. So I want to take you through 3 of our platforms to talk a little bit more about when I started, I talked about how we design in a different way. We work in a platform level, not a project level. And the first one that we're excited about is this mid-rise multifamily, or mid to high-rise, I guess you could call it. But with the new code coming out, and a lot of states are early adopters, including Washington and Oregon, this Type 4B is a sweet spot, we think. This 12-story mass timber multifamily product, we think, is going to really take off. And the way we look at it is there are a couple ways to take advantage of this. One is we could just go straight up 12 stories multifamily, but then you're leaving a lot of height, because you can go 12 stories. You can also go up to 180 feet. So another model that we're looking at as part of the platform is inserting a loft space. So at maybe every other floor you've got loft units that have a little second floor bedroom loft. And that allows you to get up to that 180 feet, take advantage of that height, add a little bit more rentable area. Another way to do it, of course, is just to build a taller podium. So you can go Type 1 up to whatever you need to get to as far as podium goes, and then take the rest of the way up to get to 180. So these are all part of the platform we're developing within that Type 4B. And this is essentially the kit of parts that we're working with. And specifically around the CLT panel, our press 12 by 60, so not cut down to about 11'9" in width after we trim the ends. And so what we're looking at is the most economic way to take our panel and utilize it for our products. So this is what's unique about having our own factory, we can design our product line around our factory capabilities. We want to use every cubic inch of fiber that's put in that press every single time, because that will drive the cost of that product down significantly. If we have zero waste coming out of the factory, then we're going to have a very, very good price point on that CLT. So we're designing our products around that. This is taking advantage of that 30-foot long, 5'9" wide panel, and very, very efficient structural system. What that means is now, instead of starting with unit planning, we're adjusting our unit planning to the manufacturing capabilities. So we're working backwards and saying, if that's the most efficient way to get material out of our factory, how can we design unit plans around that? Be very, very strict. If these are 15'6", then we're kind of screwed, right? Because we've got a 60-foot long press. So just it's a different way of thinking about design. So this is our kit of parts. This is kind of a standard, very hypothetical building that we started with. And then if you blow this up and look at the components that go into a mid-rise multifamily building, you get back to that initial diagram that I showed you. So we already have a lot of this stuff designed. This is in our catalog. We can throw this right into this next platform and be ready to go. Now we just need to take anything that's new with this platform and pull that in to make it real. So this is an example of how you can rearrange that on a specific site, use that same kit of parts, and end up with, in this case, this is 12 stories of mass timber over a podium. And this is actually a real project that I'm showing you. So this is one that we have going in the Pacific Northwest right now. Very narrow site. This is typical now that these sites are becoming more and more challenging. This is perfect for mass timber, though, because it will go together so quickly and have such a small disruption on the site. There are 50% fewer trucks delivered on a mass timber site than on a typical PT concrete site. So that's very appealing to the city and neighbors, and also to our construction team. So this is essentially how this building is put together. We've got this beautiful timber tower on top of a podium. In this case, we have an automated parking system because the site is so narrow. That's the only way to get the parking to work. So we're excited about that platform. Another one that this is completely changing gears is you wouldn't think of mass timber being used for light commercial, but we see a massive opportunity out there. And our goal here, and I think this is a safe thing to say in this room, is to completely, to essentially provide a fresh alternative to tilt-up concrete. I'll just put it that way. We think using our CLT for exterior walls of light commercial is going to be the way to go in the future. And there are a number of customers who are jumping on board and are believers in this as well. So if we can drive the cost of this product down to be very competitive with tilt-up, who wouldn't want wood on the inside of their building, and who wouldn't want to be able to tell that environmental story, that carbon sequestering story? It's just a much better product. The other thing is we can provide a design that allows you to remove those lower panels. So if you ever want to switch things out in the future, that's so much easier to do here than it is with tilt-up concrete, right? So we're designing this system. Again, this is designing a system around the factory capabilities. So we're looking at how we can fully utilize our master panels. And we can use these in a combination of horizontal and vertical combinations. And we can create a catalog that can then be plugged into a parametric model. And depending on the customer's inputs of the span, the height of the building, the number of roll-up doors, those kind of things, we can let the computer do a lot of this design work for us. So the engineering can be part of this parametric model, and it can all be based on our master panel. So every one of these options that we're looking at, we're making sure we're trying to maximize no less than 90, hopefully no less than 95% utilization of our master panel. So we're working through studies of this right now. Also looking at things like, what if we just simply had an allowance for openings that's part of the model? So in this case, you can see we've got only 5 master panels required to do this facade, with 600 square feet of opening that can be divided into storefront or roll-up doors or whatever. Here's one where you can double that. You get up to only 13 master panels, and you get 1,200 square feet of opening. So if we come up with these formulas that fully utilize our master panels and make it very easy to put this together, you can imagine what this does to the cost of this product. So here's a 36,000 square foot building that can be put together with only 38 master panels. So we did some calculations and determined that when our plant is operating at full capacity, and we've got 2 shifts going 7 days a week, we can actually produce enough panels to skin a 100,000 square foot distribution center in 1 day. And that's pretty remarkable when you think about that. So compare that to any other type of construction. To have that kind of output, provide that kind of output to this market sector, we think there's a lot of potential. So these are various configurations. This one I think is interesting with a 23-foot grid. We can actually now create a head that's at about 14 feet, and that's perfect for a mezzanine. So this is another part of the parametric model that can be plugged in. And then the last platform I'll talk about is the mid-rise office platform. So we are also working on an optimized version of commercial office. This is either a 4, 5, or 6-story commercial office building. And again, there's kind of a minimum set of inputs that we need from the customer. There are different lobby configurations. Of course, there's going to be different seismic considerations and things like that. But much like with our multifamily platform, what we're looking for is how many of these things can we set up front and make consistent every time, and then only allow that modification where we really need it. And then how can we drive cost out of this? So we started with what is the most economical building structure you can do for this particular span. This 120 by 240 office plate is very ubiquitous across the entire country. That 30,000 square foot floor plate, you see it all over. So if we can span from our core all the way to the outside wall with one column, and if we can do double span with all of our CLT panels for efficiency and vibration control, then we can really drive the cost of this down to where we can compete with any other building type at this size. And then it's also, utilizing that master panel. So if we're cutting 40s and 20s out of our master panel, we can take those 20s now and use them around the core where we have a higher load requirement. So we can get really creative with our structural engineering team and provide a solution that uses every one of our master panels and, again, drives the cost out of this product. Various configurations of the lobby and back of house and different configurations for the restrooms. So again, providing that catalog of opportunities for the customer. We can provide conference room kits, and a lot of our interior finishes and things like that can come right out of our catalog. And then we're working with our partners at McKinstry to develop mechanical, electrical, plumbing cloud or appliance that they can plug into the ceiling, of course, leaving all of that wood exposed, but coming in with a prefab approach to our MEPF systems, just like we're doing with the rest of the building. And then on the exterior, multiple options again, trying to stick to a 40% glazing so that we can use the prescriptive code just about anywhere across the country. Customers would be able to move away from that if you want more glazing, if you want to spend the time to go through a performance-based approach. But we want to have it available in our catalog to make this very, very quick to get to market. So if we can cut 50% out of the design time to get to permit, and then another 30% out of the construction time, that's a big deal to these customers. So that's our office product. And I just want to end with one thing. Is Mark Wishney still here from the Nature Conservancy? I don't know if he's around still. He may have left. But I was on a panel with him earlier this year, and I asked him if I could borrow a couple of his slides because I like ending with his story. And he probably shared this with some of you yesterday if you heard Mark Wishney speak. But the fact that the Nature Conservancy, with their 10,000 members and 600 scientists on board, see mass timber as a potential lever to pull on climate change, that gets me really excited. And so I like ending with that this is not just about disrupting the industry, but this is about building in a smart way and doing something that I'm really passionate about, and that's building more responsibly. So, Mark tells a story about how the biggest change we can make, they've done a lot of work on this, is reforestation. But the reforestation is massive, right? I mean, you'd have to reforest this area. What does he have? Like the size of, what does he have? Combined area of France, Spain, Norway, Germany, Italy. So, I mean, that's just not going to happen very quickly. So the way to leverage mass timber is by not just building hundreds of these buildings, which we have on the drawing boards right now, but we have to change the industry and build thousands and thousands of buildings in this way. And this is what they believe too, and this will make a difference. And he ends with this chart that shows the growth cycle of a forest. Each one of those vertical lines is when you're harvesting. And so you're taking that sequestered carbon, you're putting it into a building, and you're storing that carbon for the life of the building. And then you're replanting, and you're growing that again. At the same time, you're taking all of that carbon that would be lost to the atmosphere through manufacturing of cement or steel, and taking that off the table. And that's in that lighter gray area. And so even when at the end, even when you subtract for the embodied carbon that goes into doing mass timber buildings, that's in that red line, you can see the dramatic difference it makes if we start building in this new way. So I like ending with that. The two things that I'm most passionate about are providing good housing for teachers and firefighters and architects and interior designers, that workforce housing that gets ignored, and also doing something that's right for the environment. So those two things I feel like are two of the core missions of Katerra, and those are the things that get me up in the morning and keep me excited about working there. Thank you.